The basis for the modern chemistry was the Daltons atomic theory. He presented it in the year 1803. Dalton said that every matter is made up of tiny spherical particles called atoms. Also that atoms can't be destroyed or newly created. As a summary, Dalton's atomic theory included the following things. Atoms of a given element are identical, but of different elements are different. Atoms of one element can't be changed by any chemical means to another. Atoms of two or more elements combine to form compounds. Chemical combination. In chemical combination, the ratios of elements are simple whole numbers. But when Dalton presenting his atomic theory, he didn't mention anything about subatomic particles, or even about electricity. However, people of even ancient times knew about electricity. Static electricity, simple Baltic cells, electroplating are some evidences for the electric nature of matter. Cathode ray experiments. Scientists in the 18th century attempted to pass electricity through gases. They succeeded when they used a glass tube with a gas or air at very low pressure in it. Such tubes are called as cathode ray tubes, or discharged tubes. Properties of cathode rays. Cathode rays produce green glow on the glass tube at the anode side. Cathode rays travel in straight line paths. When an opaque object is placed in the path of cathode rays, a shadow with a sharp boundary is formed. This is because cathode rays travel in straight line paths. Cathode rays possess a momentum. When a light paddle wheel is kept in front of the cathode, it starts to rotate. It implies that the cathode rays can cause a mechanical motion. Cathode rays are negatively charged. Cathode rays are deflected towards the positively charged plate in an electric field. Cathode rays deflect in a perpendicular direction to a magnetic field. Fleming's left-hand rule gives the direction of movement. Cathode rays can produce X-rays when hit on a metal target. Other properties of cathode rays. They emit perpendicular to the cathode surface. They can ionize gases. They can heat up the surfaces on which they fall. They travel at very high velocities but less than that of light. When a beam of cathode rays strikes a sheet of matter, a portion of beam is scattered back, a portion stoked by the matter, and absorbed into it, and the remainder is transmitted. Important fact about cathode rays. The properties of cathode rays do not depend on the type of metal used for the cathode, or the gas used inside the discharged tube.